Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. If you have not already subscribed, please subscribe my channel. Thank you. We continue the discussion of the solutions of the problems that have appeared in the TG Set 2024 exam. This is a Telangana State Entrance Examination 2024. This question, in this video, we discuss the solution of a problem from the section Numerical Analysis, and the problem is related to the interpolation, and this problem is at the serial number 97 in the above question paper. This problem is suitable for all these examinations. Right. The given problem is if f of 0 is equal to 1, f of 1 is equal to 3, and f of 3 is equal to 55, then f of 2 is equal to. We are given 4 options. Option 1, 32, option 2, 43, option 3, 21, option 4, 39. Right. For this given function, the ideal conditions are to be assumed, namely, it is a continuous function. Let's now discuss the solution of the problem in detail. And to solve this problem, we use the Lagrange interpolation. For those of you who are not familiar with the Lagrange interpolation, I will give you a small introduction, a brief introduction I will give you. Right. Consider the following data values. N data values are there. The x0, the value of f is f of x0 is f0. At x1, f of x1 is f1. At x2, f of 1, f of x2 is equal to f2, etc. At xn, f of xn is fn. Right. It is known that through n plus 1 distinct points, what are the n plus 1 distinct points? x0, f0, ordered pair, x1, f1, ordered pair, etc. n ordered pairs are there. So, through n plus 1 distinct points, there exists a unique polynomial of degree at most n that passes through them. So, we have to pick up that polynomial of degree at most n that passes through these n plus 1 given data values. We can fit a polynomial of degree less than or equal to n to this data. This polynomial, what we are going to construct, must use these ordinates, that is f0, f1, f2, fn. Right. The Lagrange interpolating polynomial is given by Pn of x is equal to L0 x to f0 of x plus L1 of x multiplied by f1 of x plus L2 of x multiplied by f2 of x plus so on and so forth plus Ln of x multiplied by fnx. Okay, we know f0x, f1x, f2x, fnx, but what are these L0x, L1x, etc.? Where these Lix, I is equal to 0, 1 to n, are called Lagrange fundamental polynomial, and they are given by Li of x is equal to, write the factors, the product of factors. The product of factors except x minus xi. So, x minus x naught, x minus x1, etc., x minus xi minus 1, skip x minus xi, then continue x minus xi plus 1, so on and so forth, x minus xn. After writing the numerator, in the denominator, wherever there is x, you replace by xi. So, take the numerator and wherever there is x, replace by xi. Right. Then you will get this quotient, and that is the LIX for I is equal to 0, 1 to n. So, take this and substitute in this, then you will get a Lagrange interpolating polynomial. So, note what it is a general method you can use in any situation, but it is useful for small data set. Why? If the large data set is given, then computing these Lagrange fundamental polynomials will be tedious. Not impossible, will be tedious. And computing the product and their quotients, there is a possibility of committing mistakes if the data set is a big one. And it can be used when x values are equally spaced or unequally spaced. There are methods which are limited to the x values are equally spaced. But this can be used for both the situations, that is, x values are equally spaced or unequally spaced. So, it's an advantage for us. We go to the given question now. So, this is the given question. We continue the discussion of this solution. We are given the following three data values. So, x naught is 1, x1 is 1, x naught is 0, x1 is 1, x2 is 3. How are these data values, x values are given? They are not equally spaced. So, here x1 and x0 differ by 1, x2 and x1 is differ by 2. They are not equally spaced. So, the corresponding values are written here 1, 3, 55. Right. Note that the x values are unequally spaced. Okay. We are given a small data because only 3 data sets, 3 data values are given, very small. And therefore, the Lagrange interpolation is an ideal method to get the interpolating polynomial satisfying the data. Since 3 distinct points are given, 1, 2, 3, there exists a unique polynomial of degree at most 3 minus 1, that is 2, that passes through them. The Lagrange interpolating polynomial is given by P2 of x, because it is a polynomial of degree at most 2, is equal to L naught x multiplied by f naught x plus L1 x multiplied by f1 x plus L2 x multiplied by f2 x. This is the formula for the Lagrange interpolating polynomial. And that will give you P2 of x is equal to L naught x into f naught. F naught is 1. L1 x into f1 x is 3. L2x multiplied by f2x is 55. Right. So, we got this one. So, if you compute L0 x, L1 x, L2 x at x is equal to 2, then you will get P2 of 2. That will be where LIX, I is equal to 0, 1, 2 are fundamental Lagrange polynomials. We are required to find P2 of 2. So, P2 of x, substitute x is equal to 2. That means you have to find L0 of 2, L1 of 2, L2 of 2 and substitute here and you will get the answer. We continue in the next slide. For your ready reference, everything is given here and even LIX formula is also given for you. Now, L0 of x L naught of x, how to write? No, the product of the factors except x naught. That means except x minus x naught. So, x minus x1 multiplied by x minus x2. And in the numerator, wherever there is x, write x naught. You have written. And now substitute x1 is 1, x2 is 3, x naught is 0, x1 is 1, x2 is 3. Substitute here. And simplify, you will get x minus 1 into x minus 3 by 3. In a similar fashion, L1 of x. So leave the factor x minus x1 and write the remaining product x minus x naught into x minus x2 by wherever there is, in the denominator, you replace x by x1. Now substitute the values of x naught, x1, x2 and simplify. You will get minus x into x minus 3 by 2. L2 of x, write the product of the factors x minus xi except x minus x2. That will be x minus x naught into x minus x1. In the take the numerator and replace it by x2. Now substitute the values of x1, x2, x3 and simplify. You will get x into x minus 1 by 6. Right. Now the Lagrange interpolating polynomial is P2 of x is L naught x, x minus 1 into x minus 3 by 3 plus 3 times L1 of x. L1 of x is minus x into x minus 3 by 2. So, minus has come here. And 55 into L2 of x, x into x minus 1 by 6. We got it. What is that we want? We want P2 of 2. That means wherever there is x, you go back here. P2 of x will be L2 of x plus 3 times L1 of L0 of 2 plus 3 times L1 of 2 plus 55 times L2 of 2. Now what are these values? L0 of 2, L1 of 2, L2 of 2. So we have L0 x, L1 x, L2 x. Substitute x is equal to 2. Where L0 of 2, get into L0 of x, x into x minus 1 into x minus 3 by 2. Put x is equal to 2. You will get a 2 minus 1 into 2 minus 3 by 3. So this is the minus 1 by 3. So L1 of 2, get into L1 of x, substitute x is equal to 2. That will be minus 2 into 2 minus 3 by 2. Simplify, you will get 1. Now L2 of 2, get into L2 of x, substitute x is equal to 2. You will get 2 into 2 minus 1 by 6. That is, simplify, you will get 1 by 3. Now substitute here. So that is equal to L0 of 2 is minus 1 by 3 plus 3 times L1 of 2 is 1 plus 55 times L2 of 2 is 1 by 3. Right. Take the LCM and simplify. You will get 63 by 3, that is equal to 21. That's your answer. So this P2 of 2 is same as f of 2. So f of 2 is 21. Where is it? It appears against option 3. Therefore, the answer to this question is option 3. And that is the detailed discussion of the solution of this given problem on numerical analysis using the Lagrange interpolation formula. Right. I've been telling all my net aspirants, all JL, DL, whatever you get, and these sets and sets examinations. For all these things, almost the syllabus is the same as that of the net examination. Now, what the latest strategy is that you concentrate on the section numerical analysis. The questions that are coming from the section numerical analysis are appearing to be very, very easy. So concentrate on that. If you have not already studied numerical analysis, study the numerical analysis, remember the formula. It will be very, very easy. And it is very easy when compared to your real analysis where, you need a lot of expertise. So here you don't need anything, and if you remember the formula, substitute and you will get the answer. Right. So my suggestion to all of you is concentrate on numerical analysis. Right. I am sure. Right. So what it says is, suppose instead of f of 2, suppose you are asked to find the interpolate f of x. When you are given f of 0 is 1, f of 1 is 2, f of 1 is 3, f of 3 is equal to 55. Find f of x, that is the interpolating polynomial, that is, answer is f of x is equal to p2 of x. So p2 of x is here. So that you write down and simplify. X minus 1 to x minus 3 multiply x square minus 4x plus 3 by 3, so on and so forth. Simplify. Then you will get f of x is equal to 8x square minus 6x plus 1. That is precisely the interpolating polynomial f of x. Right? And in this x is equal to 2, if you substitute, you will get 21. Anyway, if you are asked to find the interpolating polynomial, the same method you can do it, but the answer is this one. That's it. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes. I'm sure we're all going to meet you all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.